All right, let's talk about wedging. Now, wedging means that you let the computer calculate multiple variations of a parameter or multiple parameters. That means basically if you're not sure what is the right number, you just try them out automatically. Now, this is a technique that a lot of people use in simulations because very often part of your job is just trial and error in figuring out what number is, creating the best results without much more behind it than just trying it. And you can automate that with the wedging process. Now, over the years, there are multiple ways of wedge nowadays, and I want to show this on a simple example. What we have here is a root system. You should know how to do this at this point. We have a source, which is a volume so that we can scatter points inside. And in the pop net, I have a pop wind, actually two pop winds, one for a secondary noise, but the main one is the first one that just moves our points upwards and adds a curl noise on top of that. They then die after 1.5 seconds, I think it was here in the lifespan. And afterwards, I take those points, and since the point number is changing, we have to use the trail plus add trick to keep it stable. And then we use a sweep to thicken it up a little bit and give it some color. And with the right environment, that kind of feels like, a desert bush or something. So let's have a look how we can create multiple variations of that. The first way is kind of the old school way, and that is by using the ROP environment. Now you could use the out environment, which is the same, but I created my own ROP network. So the node is called Wedge, and this node takes care of creating different variation. What it needs is something to save that variation, and that is the output driver. So what we need here is some kind of node that saves out the result as a cache. And one thing you could use here is the geometry ROP. This is basically like a file cache on the ROP level. We will use the file cache in a second, but for now this is the most straightforward way to understand. And here is the path, and what we want to use is a classical, name of the file subfolder and then the name of the node as a subfolder of that. Let's call this ROP wedge or something. And we only need the current frame, which is, somewhere at the end so that we can save the final result. And also what we need for this node is what is it supposed to actually save? And this is what you put in here in SOP path, because, on the SOP level, we would have just an input from the top. Here we need to tell it what node we want to actually save. So let's find that. And the best way of doing this is actually create a null for it. So let's call this out sim. And if we go back into our ROP geometry, we can find that thing, and this one is called ROP wedge here out sim. There you go. Let's quickly test this by pressing save to disk, and what we should get here is a folder called ROP wedge based on the name, and then here we should have one file with a current frame. That looks good. And this thing is just saving the whole thing out. So let's take this as the output driver. This is what will be fired for each variation, and we can just drop it in here actually like this. And then we can define how many variations we want to create in the number of samples. Let's say 10. And this system is a so-called push system, which means you can define here what parameter you want to override. So the parameter we want to change in our setup is in the popnet, the pop wind 1, and here you could use the offset to create different versions of the curl noise. So this is the attribute we want to change. So let's do a right click, copy parameter to find it, and then we go back into our ROP environment, and here we define under channel, this is the parameter we want. You can drop it as a relative reference or an absolute reference. I prefer absolute, and here, out of a habit, so to say, it creates this weird parameter here, but we really just need the whole address. So let's get rid of this. So there you go. This is the address of the parameter we want to change, because we want to create 10 different variations for this parameter, and then we need a range for this. So for example, we want to try 0 to, 10 to keep it simple. And that means our offset in Y will have some variation between 0 and 10. Now by default, this will be completely random, somewhere between 0 and 10, as if you would use a random function, which can be helpful. But if you don't want that, just turn this off. And now you can define here how many variations you want inside of this range. So be careful, this is not the steps, this is the number of steps. So you have to put this up to, let's say 10 in our case. And this will now, in a regular fashion, split up this range in 10 equally sized variations. So of course that means 0, 1, 2, 3, and so on. So let's see what happens. If I press render wedges now, you will see that it takes longer. And if you look down here, you can see that it actually now reruns the simulation 10 times, each time changing the offset parameter in our popwind1, running the wedge up here, and then saving the result. Now the problem is when we look into the folder again, I only get a single file, not 10 as I would have expected. And the reason is that this file was now overwritten 10 times. Because in the naming convention we put in here, there's nothing that changes for each variation. The hip name is the same, the name of the node is the same, and the current frame, the end frame, is the same that we are rendering. So what we need here is an additional indicator what version we have rendered. And this is where the $wedge comes in. There's also wedge num, so it's up to you really what you want, because what wedge means is what has changed, and wedge num is which number of those variations is that. So is it the first version or the second version or the third? So let's go with wedge because I think it's the most useful. And this entails the name of the parameter that we have changed, which we defined here under name. So let's run this again with render wedges. And again, it will resim our bush 10 times with a different offset parameter. And now what we get in our folder is actually this, where we can see the name of the attribute and the number it used. And okay, I was a bit wrong. It took something else than 1, 2, 3, which is a bit annoying. So let's delete all this and try it again. And also what you can see, it added wedge in the front. So let's change this. And the wedge comes from the prefix up here, which we don't necessarily need if we don't want to. And I think what I have to do is I have to change the range from 0 to 9 instead. Because, if it starts at 0, then only to 9 it will be exactly 10. Otherwise, we have 11 different variations. Because then the difference between the two is exactly 10 and we will have a rounded number. So let's run this again. And now, of course, again, 10 different sims will run and the result will be saved via our geometry node. And there you go. Here's the result with 10 different variations of the offset parameter. If you would have more parameters, then it would be added to the naming. If you found this weird, then you can again use, instead of wedge num, because then it's only full numbers instead of putting in the name of the parameter. But that's details. Feel free to read up a little bit more about this or play around with it. Let's quickly have a look at the result of this. And I simply use a couple of file nodes to read this in, because that's the easiest way of doing it. So a second version would be the second version, the third version would be the third version. A little bit annoying, but that's now the quickest way of looking into it. If you would have used the wedge num, it's a bit easier, because then you could then read it in with a frame number as a indicator. But here you can see we have multiple different variations of our bush created now automatically. And that's the whole idea of the wedging. But in case you don't want to work with an additional ROP geometry, you can also use a wedge to control a file cache on the SOP level. So maybe you prefer to have a file cache here, and we use the same logic. Let's use the explicit, and then we use a subfolder with the name of the file, and then a subfolder with the name of the node, and let's call this file cache wedge maybe. And then we have to put in here somewhere the wedge information. So this time let's use the wedge num, and we want a single frame. And what you have to do now is in the ROP, in the wedge, first of all, let's get rid of the prefix. We use as a driver, not something we have in the ROP context, but we use the file cache that we just created. There it is. And here you will find under this node, and this is why I didn't show it first, in the actual node that is used for rendering. So when you know what to look for, this is the one you need. Then we don't want random samples, but we want the parameter that we saw before. and we want a range from 0 to 9 as we've learned, and 10 different variations of that. So this will do the same. So let's press render wedges, and again 10 versions will be rendered, but this time it's not using a ROP geometry but the file cache node to save it out. And if we did everything right, then there is a new subfolder called file cache wedge, and in here we have 10 different variations, and this time I used wedge num as an indicator, and here you see now it's just 0, 1, 2, 3, 4, 5 to 9, which is maybe easier than having the parameter name. But again, if you have multiple parameters you're wedging, then it makes sense. Now there's an alternative to this. This is kind of the old school way. And we've already seen in the basics chapter that there is a new pipeline tool called TOPS. And in here, of course, surprise, there is a wedge system as well. It's very similar. It's just that now you can connect those nodes. So the wedge here, you can define what parameter you want to change. So you have two options here. You can either use a push mechanism that we just saw. So you could use a target parameter and then choose it here, or you just drop it in again. And this will make sure that you change that particular parameter with every change. So you push it into the parameter and just give it a name. Let's call it offset or something. And in this case, we want, let's say, an integer and a range of 0 to 10 again. And here you change the wedge count up here. And the random samples is turned off here. So as you can see, it's a little bit different, but basically the same logic. As an alternative though, we could not use a target parameter, but simply use an attribute name. And this is called a pull technique, because now we don't override the parameter we want to change, but we use an attribute here that is automatically created when we just use an attribute name here. And this is actually described here. No, it's not described, but this is what you have to know. And to now change this for every variation, we have to go back into where we want to change our setup, and I have my own copy for this called top wedge. And in here, I have to manually override this offset with basically a global attribute now that is available for all parameters when we run our top wedge. And this is now called offset because that's what I called it. So the offset attribute that I defined in the top net, in the wedge, there it is. This attribute will now change for every time I run this to a number between 0 and 10. And of course, now we can right click, generate node, and then we can see all the tasks that this wedge would generate. And with middle click on each of the tasks, you can see, okay, here is our attribute, it's called offset, and it will have for this particular task the value 3. And the wedge index of the task that we will use later on is 3. And so you can double check if everything is all right before you run the whole thing. But this still doesn't save the different variations. It will just create them. So we need a second step. And that is, for example, another ROP geometry that I have to create. And of course, this time we set it to single frame again because we only want the end result, and give it the right naming. And we use the old-fashioned one we already saw. And just like we've seen before, this ROP geometry works the same in TOPS as it works in the ROP environment. You have to tell it what you want to sim. And I've prepared this already. In the top wedge, there is an out sim already. And now you have to be careful because this is the top world and not the ROP world anymore. The rules have changed a little bit. You cannot use the wedge and wedge num as we've learned in the old school system. The new system, as we've seen, works with attributes. So what you do here instead is you use our special symbols here that we know from the OP input path, and then you add an attribute here that you want to integrate. And one that we've already seen is we can use the offset attribute directly that we defined up here. And then it will write in here the value that is used in the pop wind directly. Or if we don't want that, we can use instead another magic attribute called wedge index, which is the equivalent to wedge num. But unfortunately, this is what you have to use when you work in the top world. So it's a similar logic, but slightly different. And as you know from TOPS, it's a bit weird now to run this. You don't just look through it or anything. You have to actually right click and say cook node. And then it asks you to save the file. And once you cook this node, because it's connected to the wedge will run as well. And each task here will fire its own version of the ROP geometry. And what this will result in is a new folder called ROP geometry with 10 different variations in it. And here you can see this number over here is the wedge index that we put in. Yes, the naming is a bit horrible, so there are a couple of things that you can change here. So for example, ROP geometry 1 is a really bad name, so let's call this maybe top geo. And then let's see, maybe we don't need the frame. By the way, let's make sure that we overwrite the frame to one particular one, maybe 1150, which makes it more stable. And what else we don't need? Maybe we don't need the hip name because there is, it's called Wedging 000, which is confusing. And I think we're good. So let's try this again by right-clicking Cook Node and save. And once it's done, we have a nicer version of this called Top Geo. And here I think now it's much easier to read because we have the wedge number in the front. So of course, you know, you have to find your own variation of this whole technique, but it's basically the same, just using tops. One advantage of using tops, as we've learned, is it will not just run the simulations one after the other, but in parallel. And especially in a case like this, our pop simulation, which is super simple, this sped up the whole process by a lot because it was able to use multiple processes in parallel. And this is why it was much faster, even though the other one was fast as well. And then I want to show you a third variation of this. If you have the Labs library installed, then this actually comes with its own version of the file cache called Labs file cache. And the special thing about this is that it has its own wedging parameter in here, where basically everything is already built in the file cache, which can be pretty handy. So let's say we want to save a single frame, and let's overwrite the frame to 1150. Then we know the drill. We create an attribute. This time this works with an attribute name again, so it's a pull mechanism. So let's call this wedge attrib this time, and we give it a certain custom range. Up here there is the wedge count is built in here, so let's say 10 variations from 0 to 10. And this wedge attribute we now have to use in our simulation again, which is now in the same SOP environment. So here in the PopNet, we just override the offset here with the attribute that we just created called wedge attrib. So it pulls the attribute from the file cache node. And let's actually call this now Labs file cache maybe, so that we later know where this comes from, because we want to use that name in the naming. So the subfolder is again the hip name, then the name of the node. And in here, again, the question is, how do we put in the wedge functionality? And this is again the same as in tops, because as you can see on the icon, it's actually a tops system here built into the Labs file cache. So what we can do is we can use, again, wedge index, for example. Make sure you put in the special tick boxes here so that will actually be calculated. And if I haven't missed anything, we should now be able to run this. Now be careful, don't press save to disk. Otherwise, what will happen is you will just get one single version of this. To really create the wedged version, you have to save in background. And then of course it will ask you again to save, because internally it's a top system. And then it starts doing its thing and creates 10 different variations. And the result of this is 10 different variations in my Labs file cache subfolder. So as you can see, you have plenty of options how to wedge with tops, with ROPs, or with a Labs file cache. What's important to understand is the old system has a push system. So this node, the wedge node, will push a change to a particular parameter. The newer system, the top system, has two options, the push and the pull system. So you can either directly push the attribute into the parameter, or you just write it into a variable so that the parameter that you want to change can pull that attribute itself. And this is kind of indirect, a pull way of changing your variations. It is a bit fiddly the first time you do it, but the more often you do it, the more, you get used to it, especially if you found your way of doing it. Now, what we use this for is really just to create different variations of something. Even though this is a pop simulation, we only saved the last frame. Later on we will see that we can do this with simulations as well, but this is kind of an easy introduction into the whole topic. So for now, play around with this to get a feel for how wedging works. I hope this is helpful. Thanks very much and see you later. Cheers.